Hello, everybody. Here we are, last part of the unit 4.5, using graphs to estimate values. So I've got a few definitions to start, and I added a few as well. So first one, interpolation. So estimating a value inside a data, a set of data points. Okay, so think about the word inter, okay, inside. And extrapolate is estimating a value, take a guess, outside a set of data points. Okay, so think about the word extra. Extra is, above and beyond. It's like over the top, it's outside of kind of what's expected. So extrapolate. And you say it like extrapolate, not extrapolate, but, to each their own. And the next one I want to talk about is discrete. This means that, say our data points are distinct from each other. So that's not a very straight line. But I was thinking about, okay, in our textbook, there is an example of tables versus like number of seats. So as the number of tables goes up, say 1, 2, 3, 4, 5, the number of people that can sit at these tables is increasing like this, increasing like this, increasing like this. And we use these, we represent dots here because, and we don't connect these dots because there's no half tables. There's no, 1 and 1, 3/4 of a table. There's just discrete numbers of tables. They're countable. We sometimes, in English class, use the word number when you can count something, and use the word amount when it's not countable. So you could say we have, a number of students in the class who are in PLP, or you could say, the amount of, I can't think of an amount at the moment. The amount of energy I've spent, on something, et cetera, et cetera. So we use number for countable and amount for not countable. Just like for continuous. So if we did something like this, okay, maybe let's say distance from home. It's hard to read over time. So it might look something like this. And we would use a solid line because every single second and millisecond is counted in there, and every little bit of distance is counted in there as well. So it's a continuous amount. And it exists all along the line, whereas the discrete part does not, because they're more countable. So I thought that might be helpful, just those two words, when we look at data and talk about data and think about data. So let's get into our questions here. This graph represents a linear relation right here. Determine the value of x for each value of y. So let's look at y. Remember, this is our y-axis right here. So where y equals 1, that's it right there, we would say that x, this is our horizontal axis, equals 0. So x equals 0. Now let's look where y equals 3. So maybe I'll use another color here. So y, there's where it's 1, 2, 3 there. And then let's move it over to the x-axis. We can see that x equals 4. And finally, let me erase that little dot. Do another color. Where y equals 0, so this is our y right here, equals 0, x equals -2. Okay, and since all of these dots exist on our line, we would call this interpolation. So it exists within our data set. Okay, so it exists within our line. So we found that data from inside our line. Let's try the next one. Determine the value of each y for each value of x. Let me do some different colors again. I like the colors. Where x equals 2. So there's where x equals 1 equals 2 right there. And then let's look on our line right here. So when x equals 2, y also equals 2. So let's go y equals 2. Let's do another color, purple. What about where x equals 8? Okay, so this is going to be off of our existing line now. That's kind of fun. So let's extend our line. It looks like it's going up 1 over 2, up 1 over 2. So there's going to be another dot. There's going to be another dot. There's going to be another dot over there, kind of off the screen now. So let's connect those ones. So now let's go back. So this is where x equals 4, 5, 6, 7, 8. 8 is right here. So we went up from there. There's our point. So where x equals 8, y would equal, there's 1, 2, 3, 4, 5, it looks like. Okay, so y is going to equal 5. And what about when, what color do we want to, let's do that one, where x equals -6. So now we're way over here. We're off our existing grid as well. So we're at -2, -3, -4, -5, -6 is right there. And so there's our point that we're looking at. And it looks like y is going to equal -2. Oh, I don't know if you can read this color. Can you? -2? That seems like not a very readable color. Let's just do black. Y equals -2. Okay, so because these two existed outside of our data set, that is extrapolation. This one was still within our data set. That's interpolation as well. Okay, there you go. So these two existed outside of our line. They were over here and over here outside of the line provided. So that's extrapolating. And this one here, I existed within our line. And so that's interpolation, just like these ones over here. So let's go down to this question. I think we just have the one. So let's see. The graph shows the cost of long distance call changes. I think that maybe means charges with the call charges with the time for a call. Estimate the cost of a 7-minute call. Is this interpolation or extrapolation? Explain. So here we go. Let's look at, here's 5. That would be 6. That would be 7. So let's go right up here. There's where it's going to be right there. Let me just zoom in a little bit. So it's going to be there. It looks like it's, for each of these are all 5. So it looks like it's kind of halfway in between right there. So I'm going to make a little kind of dotted line. So I'm going to estimate the cost of a 7-minute call. I'm going to estimate it at 0.55. So we're kind of halfway in between 5 and 0.60. So I'm going to estimate $0.55. And this is interpolation because it is inside our data set. Okay, so it's within the line that they've given us. That's interpolation. Let's look at the next one. The cost of a call that was $1. Okay, so here we go up here. This is going to be outside of our data set. First, let's extend our line. Actually, I'll do it with this color right here. So it looks like we're going up. Let's look at I want to get the slope right. So we're going up 1, 2, 3, 1, 2, 3, 4, 5. Okay. 1, 2, 3, 1, 2, 3, 4, 5. There's a dot. 1, 2, 3, 1, 2, 3, 4, 5. There's a dot. Let me connect that. There we go. So at $1, the line's going to be about there, which let's make a little dotted line down to here. 11, 12, 13, 14, I would say. So the cost of a call is $1. Estimated time for the call, 14 mins. This is extrapolation because it's outside our data set. And the last one, the cost of a call, that was $1.50. Estimate the time for the call. Okay, so we gotta extend this up this way. Up here, that's $1.10, $1.20, $1.30, $1.40, $1.50 right there. And so our line is going to go right to here. So what is the very end? Let's look. That was 14. That's 15, 16, 17, 18, 19, 20, 21, 22. Okay. So I'm going to say 22. Let me do my blue. 22 mins. And again, this is extrapolation because it is outside our data set. There you have it. I will let you know what textbook questions I want you to work on, and thanks so much.